Hello everyone, we are now going to go through this worksheet on chapter 14.2, which was on regression equation. Now in this worksheet, the first few questions are just testing our knowledge and understanding of the concepts behind the regression equation, as well as some of the terminologies that we will use or that will be used in this topic. All right, related to this topic. So the first question says, regarding a scatter plot, identify one of its uses. So we have to first know what a scatter plot is. So I'm going to step back a little bit and start with what goes behind the scatter plot. Scatter plot, we understand, is a graph, but why do we need a scatter plot? And that will tell us, in fact, that will tell us its use. All right. So for regression equations, especially for our course, we are studying regression equations with one independent variable. So we said before that for regression equations, we need two variables, correct? We need two variables. There's going to be an x variable and there's going to be a y variable. Now, the x variable is referred to by different names. It can be called the input variable. It can be called the independent variable, or it can be called the predictor variable. Y, on the other hand, is also known as the output variable, the dependent variable, or the response variable. So we can refer to these two variables using one of these terms. Now, initially, when we collect our data, we just get a bunch of x and y values. At that point, we don't know whether they will, if there's any relationship between the two variables at all, leave alone what kind of relationship it has. All right. But since we are talking about linear relationships here, there can be non-linear relationships as well between variables. But for our course, we are only focused on the linear relationship. But when we are given the actual data, there's no way for us to know whether there is any relationship between the two variables, and if there is, what kind of relationship they have, right? So the first step to get some direction with the two variables and their relationship is to plot the x and y variables in a graph. So we can write the x, y variables as x comma y, which would represent a point, correct? We learned in algebra before that a point is represented with x comma y, or it's called an ordered pair. So, and we will be given a bunch of these. So there can be x sub 1, y sub 1, x sub 2, comma, y sub 2, x sub 3, comma, y sub 3. There will be a bunch of these data points, which will represent different points on the coordinate system, all right, on a graph. And we just plot the points. Initially, we just plot the points, and just plotting those different values as points is called a scatter plot. It's called a scatter plot because most likely these points will be scattered all over. Sometimes it'll have a pattern, sometimes it won't, but there will be a bunch of points all over the graph. We don't connect the dots on a scatter plot, all right? They are just left as dots or points. And then once we have our plot, we see whether it falls in a pattern, all right? So first, plot the points. So we plot the points. And then once we plot the points, we check if the points are arranged in a line, in a linear fashion. Check if the points are along a line. Now, they will not be absolutely on a line, but if they are appearing along a line. So if there is a line like this, or well, if we have something like this, all right, something like this, another like this. This picture here kind of gives us an impression that yes, they seem to be aligned, they seem to be appearing in a linear fashion as a line, right? So if we draw a line like this, then the points will be along the line. So if it meets that kind of criterion, that means if the plots appear along a line, then we can conclude that yes, we can perhaps come up with a regression, a linear regression equation. So the purpose of the scatter plot is to visualize. So purpose is it enables us to visualize if there is any relationship, enables us to visualize or to understand or to realize if there is any apparent relationship, if there appears to be any relationship between the x and y variables, between the x and y variables. So that's the purpose of the scatter plot, and we begin our work on regression equations with a scatter plot, all right, using the actual data. Now part B says, what property should it have to obtain a regression line for the data? The property is what we just said. The points in the scatter diagram should be clustered about a line. So the points, all the individual plots, the points in the scatter diagram or on the graph should be clustered along a line, should be clustered along a line. All right, so that's the answer to part B of this question. Now question number 2 says, regarding the criterion to decide on the line that best fits a set of data points, what is the criterion called? So the criterion that we use to come up with the line that best fits a set of data points is called the least squares criterion. All right, and we'll go through an example problem to work out this least squares criterion, the least squares criterion. All right, so the line that best fits a set of data points, because when we have our scatter plot, we could draw several lines through these points, all right, in so one like this, another one like this. Now which one would be the best fitted line for these plots? All right, that decision, which line we should choose as the best fit line, that decision is done using the least squares criterion method. Now part B is asking what is the criterion, so we have to describe what the least squares criterion is. So I'm going to read it out. I have it written down here. It says the criterion is that the line that best fits a set of data points is the one that has the smallest possible sum of squares. So there is a squaring involved, and then there is a summation of the squares of what? Of the errors. But what are errors? Errors are the differences between the actual and predicted y values. All right, so errors are nothing but the distance, how far the actual values are from the predicted y values. What are predicted values? Predicted y values are obtained from the equation. Okay, obtained from equation of the line. Whereas the actual y values are obtained from the data set. All right, from the data set, from the sample that we are working with. Okay, so that's how you're going to explain the least squares criterion. It is the line that has the smallest possible sum of squares of the errors. In fact, it's sigma e squared. If e represents the error, that is the distance of each individual y value from the predicted y value, actual y value minus the predicted y value, if that represents e, then you have to square all the e values and then at the end sum all the squared errors, and that's what the least squares value is. And whichever line has the smallest least squares will be considered the line of best fit. All right, for question 3, regarding the line that best fits a set of data points, what is the line called? It's called the regression line. All right, let's change the color. It's called a regression line. And what is the equation called? It's called a regression equation. So the word regression is important here. Regression equation. Right, so number 4 says, regarding the two variables under consideration in a regression analysis, what is the dependent variable called? The dependent variable is the y variable. Okay, it's the y variable, whereas the independent variable is the x variable. All right, the x is considered to be, or is called, the independent variable because you can plug in any value for x into your regression equation and you will come up with a value of y. Now, y is dependent on the specific value you choose for x. All right, so that's why y is termed as the dependent variable. Question number 5 is another fill in the blanks question. Using the regression equation to make predictions for values of the predictor variable outside the range. So outside the range of the observed values of the predictor variable, the process is called extrapolation. It's called extrapolation. So when we use our regression equation that we find for x values which are not a part of the data set, outside of the data set, to find the values of y, we call that process extrapolation, using the regression equation to make predictions for values of the predictor variable is the x variable outside the range of the observed values. That means x values which are not a part of the data set. When we plug those x values into the equation and obtain a y value, that process is considered or called extrapolation. More fill in the blanks here. It says, in the context of regression, and blank is a data point that lies far from the regression line. An outlier, anything that lies outside the normal set of data points, all right, is a data point that lies far from the regression line relative to the other data points, is considered or called an outlier. And then B says, in regression analysis, and blank is a data point whose removal causes the regression equation to change considerably. An influential observation. So when we remove a particular data point because it seems to be an outlier to us, and we see that the regression equation has changed considerably, then that particular data point that we had removed is called an influential observation. All right. Now, question number 7 is about applying the least squares criterion method to decide which of these two lines is the line of best fit. We have line A given with the equation y equals minus 1 plus 2x, and line B has the equation y equals 1 plus x, and this data set in the table here represents the actual data that we used to come up with these two lines. And remember the steps. The way we go about finding the equations is first create a scatter plot using your actual data, and then draw some lines through those scatter plots, and then we will decide which ones would be the line of best fit. So here part A says construct tables for x, y, y hat, e and e squared. So we are given these tables. One will be used for line 1, the other one will be used for line 2, and once we walk through these tables, we should be able to come up with the line of best fit by looking at the sum of the e squared. All right. So what is the equation for the line 1? Let me write it down here. Line 1 has the equation y equals negative 1 plus 2x, and line 2 has the equation, but we can also call it A and B. All right, the equation with line B is y equals 1 plus x, and we will need to use these equations to come up with the y hat values. All right, y hat are predicted values that are obtained from the equation. So for the first two columns, we just write down whatever values are given to us for x and y. So x is 1, 2, and 3. For corresponding y values are 3, 1, and 5. Now that we have completed the first two columns, the next column says write the values of y hat. So to get the values of y hat, you have to plug in the x values, all right, into this equation and calculate the y values. So these are actually should be y hat. All right. So the first one is 1. So I'm going to show you the work here. So y hat will be negative 1 plus 2 times positive 1, which is negative 1 plus 2 is a positive 1, correct? So y hat is going to be 1 for the first one. The next one is y hat equals negative 1 plus 2 times 2. That's negative 1 plus 4 is a 3. So our y hat value will be 3 for the second row. And then the last one is y hat equals negative 1 plus x is 3 for the last value. So 2 times 3, which is negative 1 plus 6, which is a 5. So you write your y hat values. Now we have to calculate E. E represents error, which is the distance between the actual y value and the predicted y value. So you can write the formula for E. It's y minus y hat. So 3 minus 1 is a 2. 1 minus 3 is a negative 2. And 5 minus 5 is a 0. So we got all our E values. Now we have to square them up. So 2 squared is a 4, negative 2 squared is also a 4, it's a positive value, and 0 squared is a 0. So we sum them up. So sigma e squared gives us a value of 8. So that's the sum of the squared errors. All right. So sum of the errors squared is 8. Now we have to work through the second table using the second equation, for the second equation rather. So get same values for x and y. So 1, 2, 3, the actual data, 3, 1, and 5. But now it's a different equation. So let's do the work here. Y hat equals 1 plus x is 1. So 1 plus 1 is 2. So we write the value 2 in the first row. And then y hat is 1 plus 2 is 3. So 3. And then the last one is y hat equals 1 plus 3, which is a 4. So 2, 3, and 4. Again, to calculate your e values, all you do is take your y values and from it subtract the predicted y values or y hat. So 3 minus 2 is a 1. 1 minus 3 is negative 2, and 5 minus 4 is a 1. 1 squared is 1, minus 2 squared is a 4, and 1 squared is a 1. Sum them up. Just need to sum up the last column for e squared. So 1 plus 4, 5, plus 1, 6. All right, so now that we have our summed up e squared values for both these equations, let's see which one will fit the set of data points better. Determine which line fits the set of data points better according to the least squares criteria. Now, least means you will pick the line which has the smallest sum of e squared. All right, so of 8 and 6, 6 is the smaller value, so we are going to choose line B. All right, so we are going to say y hat equals 1 plus x fits the data better because it has the smaller sum of squared error. Fits the data points better because, sorry, I wrote over the other one, other word, because it has the smaller sum of squares. Sum of squared errors. Not just sum of squared, but squared errors. All right? So that's how you use the least squares criterion to decide on which line would be the line of best fit on the actual data that is given to us, right? Now for this last question on finding a regression equation using the computational method, on that same example on age and price of Orions, I'm going to skip this for this worksheet because there is a separate worksheet where I work through the entire example from finding the regression equation to finding the R squared values, the R values, and then performing a bunch of inferential study on this particular example. All right, so I don't want to repeat it. I will post another video, a separate video for that. All right, but I did already work this in our PowerPoint lectures as well, so you can go over it to understand how that is worked. All right.